I'm so glad you could join me. Today I thought we would take a look at this amazing book of pictures from the Hubble Telescope. This is Hubble's Universe. Greatest Discoveries and Latest Images by Terence Dickinson. Iconic images from space. In addition to being one of the greatest scientific instruments of all time, the Hubble Space Telescope has given humanity a spectacular legacy of beautiful images of the universe. The best and most recent of these are displayed and explained in Hubble's Universe. Join award-winning astronomy writer Terence Dickinson in this compelling tribute to the biggest game-changer in astronomy since Galileo first turned his 30-power spyglass to the heavens. With characteristic ease and scientific accuracy, Dickinson describes the revolutionary discoveries made possible by Hubble's quarter-century-long tour of the heavens, presenting a portfolio of images that have unveiled stunning revelations about the past, present, and future of the universe. Now, at the apex of its imaging capability, Hubble continues to enlighten and astonish a captivated audience of scientists and citizens here on planet Earth. Let's take a look inside. This is a Firefly book, printed in 2017. It was published in the United States by Firefly Books, published in Canada by Firefly Books, and printed in China. Picture of Messier 9, or simply called M9, contains hordes of stars swarming in a spherical cloud about 25,000 light years from Earth. It's too faint to be seen with the naked eye, and when it was discovered by French astronomer Charles Messier in 1764, he observed it only as a faint smudge in a small telescope. He classified the cluster as a nebula, or called cloud in Latin. This Hubble Space Telescope portrait, the best image yet of M9, reveals 250,000 individual stars. Contents: we have Hubble's Universe, Hubble's top science accomplishments, the message of starlight, crucibles of creation, starry tapestry, blaze of glory, Hubble's invisible universe, empires of stars, neighbor worlds, the planets, Hubble's strange universe, and then a Hubble update from 2012 to 2017. A celestial shell of interstellar gas being shocked by the blast wave from a supernova. The Ornament Nebula was imaged by the Hubble Space Telescope and combined with X-ray images from NASA's Chandra X-ray Observatory. The supernova, the explosive destruction of a star, occurred nearly 400 years ago and is 23 light years across. The nebula is expanding at the rate of the Earth-to-Moon distance is bright pink, and it looks rather like a bubble that you would blow from a bubble mix. And the inside is green and blue. And then you have stars beyond. This Hubble image is the most detailed portrait yet of the largest star nursery in our local galactic neighborhood. Known as R136, the massive stellar grouping is a turbulent star birth region in the large Magellanic Cloud. Here we have dark portions and light portions, kind of a rusty red color and cream. You have some darker sections, and then it's like an opening in the clouds here, so that you can see the beautiful cluster of stars beyond it. Let's read a little bit about Hubble's universe. The flagship of NASA's Great Observatory program, the Hubble Space Telescope is one of the most ambitious, legendary, and nail-biting science endeavors in human history. The payoff has been immeasurable. Hubble has given us the universe. Before Hubble was launched into orbit around Earth in 1990, there was lots of scientific discussions about what a space telescope might find. Hubble scientists agreed that it would be anticlimactic if, in fact, the orbiting telescope found simply what was predicted. The top to-do list items for Hubble were to measure the expansion rate of the universe, to find distant galaxies, and to determine the chemical content of the space between the galaxies. But everyone expected Hubble's most important discoveries would provide answers to questions that astronomers do not know how to ask and find objects that were not yet even conceived. Still, no one imagined that Hubble's photographs of deep space would be so utterly, jaw-droppingly beautiful, or that the pictures would have a purely visceral appeal to an entire generation, making Hubble household words synonymous with spectacular images of the cosmos. It was as though we were looking at the universe with a new eye. The crystal clarity of the images gave us a subliminal three-dimensional universe. The details were so clear and crisp that viewers were drawn into a fantasy landscape of unfathomable shapes and uncommonly vibrant colors. Hubble's incredible sharpness is due to the fact that the telescope is located just above the Earth's turbulent atmosphere, which smears starlight. This is why stars seen in a dark, rural night sky appear to twinkle. If your eye were as sensitive as Hubble's, you could look from New York City and see the glow of a pair of fireflies in Tokyo. If the fireflies were 6 feet apart, you could resolve that there were two of them side by side. Hubble's supervision has shown us places in the cosmos that no generation of humans before us has ever seen. Think about that. It's pretty amazing. And here we have a galaxy. Like no other instrument before it, the Hubble Space Telescope sees remote galaxies with unprecedented clarity and sharpness. Astronomers estimate that the known universe contains at least 100 billion galaxies, each with a cargo of tens to hundreds of billions of stars. NGC 3370, the impressive spiral galaxy in the foreground of this Hubble image, is about 98 million light-years distant and 80,000 light-years across, 1 light year is 10 trillion kilometers. Many more distant galaxies are visible in the frame. The apparently tiny ones are 10 to 50 times more remote than NGC 3370. Most of the celestial pictures throughout this book are similarly flat 2D portraits of the 3D reality of the universe. The Hubble Space Telescope's vision is so acute, it can reveal features on our neighbor worlds, in this case Mars on the facing page and Pluto above, that are invisible in much larger telescopes located on the Earth's surface. The reason Hubble orbits completely above the blurring effect caused by the ever-present turbulence in the Earth's atmosphere. So over here we can just barely see Pluto here. It has a dark shadow across it. You can see it's kind of cloudy. And here's our photo of Mars. And you can see the polar ice caps on either end. And then some darker areas. And then the lighter orange surface. Like a ghostly smoke ring frozen in space, the Ring Nebula is actually barrel-shaped. We're looking down one open end of the barrel at gas cast off by an expiring star thousands of years ago. This Hubble photo reveals elongated dark clumps of material embedded in the gas at the edge of the nebula and the dying central star floating in a blue haze of hot gas. The remnant central star has a surface temperature of 120,000 degrees Celsius, about a light year in diameter. The nebula is located in the constellation Lyra, some 2,000 light years from Earth. The colors are approximately true colors. So in the center here you have the wonderfully blue color, a slight star in the center you can see, and another one off to this side. Then you have wisps of this green color reaching in. And then you have a cream colored section bordering the green. And then you have yellow going around that. And it fades into an orange, dark orange color that fades away into the black of the universe. In this Hubble Telescope image, Sirius A, the brightest star in our nighttime sky, is shown along with its faint stellar companion, Sirius B. The cross-shaped diffraction spikes and concentric rings around Sirius A are normal artifacts produced within the telescope's imaging system. The two stars revolve around each other once every 50 years. Only 8.6 light years from Earth, Sirius A is the fifth closest star system known. Only slightly larger than Earth, Sirius B is a white dwarf. So here we have Sirius A in the center. It's quite bright. But then you can kind of see what they're talking about with the telescope. There's rings in the light given off. And then here, way back, you can see Sirius B, the other star. Here we have a photo of the Hubble Telescope. The Hubble Space Telescope, as it appeared to space shuttle astronauts after its release back into Earth orbit, following a final repair and refurbishment mission in 2009. Peering deeper into the universe than any instrument before it, Hubble examined a small segment of the night sky, about the size of a period in this book, held at arm's length. This relatively tiny patch contains the thousands of galaxies seen here, each one a celestial continent of billions of stars, with the exception of one star in our own Milky Way galaxy, easily distinguished at lower left by the spiked appearance caused by Hubble's optical supports. Everything else seen in this image is a galaxy. I'm gonna guess that maybe this fuzziness is what they're talking about. But just think about that. Look at all these amazing galaxies out there. We are just a speck of dust in the universe compared to all of the others. Approximately 500 million light-years distant, the Cartwheel Galaxy is the result of two galaxies colliding. It took 200 million years for the cartwheel shape to develop after the collision. The outer ring shines blue with the light of newborn stars. Here you have, I'm assuming where the galaxy had collided, in the center. And here it is, working itself up into the order of things. Planets, stars. The outer ring is bright white blue. And then the inner one, you can just see the faint markings of the cartwheel-looking portions. And then the twirling motion in the center. And over here we have more galaxies, background. A majestic mountain of cosmic gas and dust lies at the center of the Carina Nebula, the largest star-forming region in the Milky Way galaxy. Stars form from collapsing clouds of cold hydrogen gas. As a star grows, it gravitationally attracts more matter. Eventually, as dust within the disk clumps together, planets may arise around their new sun. I don't know if you'll be able to hear it, but I have a couple of pigeons cooing outside my window. Here we have this gaseous form making its way in the universe, and it's kind of reminds me of a piece of driftwood. Then you have orange gassy areas and darker areas. We have a bright star here and a bright star over here, and then more stars in the distance beyond. Here we have some astronauts working on the Space Telescope. You have an astronaut reflected in the shield of another astronaut as they take their picture, and you can see the camera they're holding in their hand. Some more pictures of the telescope being worked on. resembling a nightmarish beast rearing its head from a crimson sea, this monstrous object is actually an innocuous pillar of gas and dust called the Cone Nebula. This Hubble Space Telescope view shows the upper 2.5 light years of the nebula, a distance that equals 23 million round trips to the moon. The Cone Nebula resides 2,500 light years away in the constellation of Monoceros. Over millions of years, radiation from hot young stars located beyond the top of the image has slowly eroded the nebula. So here you have it. Large, you have this reddish background, very dark, ominous looking clouds, and then maybe these are the eyes. Here is a graph of Hubble probes, the early universe. In 1990, we had ground-based observatories here on Earth. In 1995, we had the Hubble Deep Field Telescope. In 2004, we had the Hubble Ultra Deep Field. In 2010, we had the Hubble Ultra Deep Field IR. And in this book it says the future James Webb Space Telescope. But as we now know, that was launched last year. And man, some of the images from the James Webb are pretty astounding. But the Hubble got us there first. It opened up our eyes to see what was there. More pictures of just millions and millions of galaxies out there. Just pages and pages of it. Could have a whole book full of all these galaxies, couldn't we? Let's look at this one. A 3,700 light-year diameter accretion disk surrounding a black hole at the core of the galaxy, NGC 7052. As it swirls around and into the hole, matter is compressed, causing a fierce storm of radiation to emerge, which blocks the 300 million solar mass black hole from view. NGC 7052 is 200 million light years distant. Wow, look at this one. The Trapezium cluster is a 4-star powerhouse that illuminates and stimulates to luminescence the vast Orion Nebula. So here's the cluster that they're talking about in the center. The 4 stars. And then you have all these gases around it. Looks like smoke, edged with pink. And then into the blues as you get farther away. This photo map, compiled from individual Hubble images of Mars, spans most of the planet's surface. Fine orange dust covers much of the planet. Coarser dust looks darker. The interplay of contrast and fine detail led the late 19th century astronomer Percival Lowell to perceive linear features through his telescope, which he thought were canals constructed by a Martian civilization. Observations of such detail were historically hampered by the blurring effects of the Earth's atmosphere, but by the 1960s, close-up spacecraft images of the red planet revealed the real Mars, a desert world of sand dunes, volcanoes, craters, and canyons, but no canals. So you'd have all these darker areas that would be like giant Grand Canyons on the surface of Mars. Let's read a little bit about this. The star that changed the universe. Astrophotography was fundamental in the discovery that there are galaxies far beyond our Milky Way. At the beginning of the 20th century, astronomers believed that spiral nebulas, as galaxies were then known, were part of our Milky Way galaxy. Two top astronomers, Harlow Shapley and Heber Curtis, held a public debate in 1920 over the nature of the spiral nebula. Shapley argued that they were much smaller than the Milky Way and therefore must be part of our galaxy, but Curtis thought the Milky Way was smaller than Shapley had calculated, leaving room for other island universes beyond our galaxy. Edwin Hubble was determined to find out just how far away the largest of the spiral nebulas, the Andromeda Nebula, or M31, really was. He spent several months scanning Andromeda with the 100-inch telescope on Mount Wilson, California, the most powerful telescope of that era. Andromeda was a monstrous target, about 5 feet long at the telescope's focal plane. Consequently, it took hundreds of photographic exposures, covering dozens of large photographic glass plates, to capture the whole nebula. Hubble made a striking discovery when he compared the plates. One of the stars rhythmically dimmed and brightened over a few days. It was a Cepheid variable star that can be used to calibrate large astronomical distances. The star turned out to be more than 1 million light-years from Earth, several times the calculated diameter of the Milky Way. When Shapley received word of the discovery, he told a colleague, "Here is the letter that destroyed my universe." Thanks to the technological advances of telescope optics and electronic detectors, an amateur astronomer with a modest-sized telescope can duplicate Hubble's discovery by observing M31 from the backyard. The Hubble telescope is so sensitive it can find Cepheid variable stars at distances 35 times farther away than the landmark Cepheid that Edwin Hubble found. So here are some photos from the early telescopes. And this is the area that they were looking at. This section. And then inside this section is a little box. And that's what this one is. Some stars in the winter constellation Orion, the Hunter, are so bright that colors can be perceived with the unaided eye alone. Betelgeuse is a cool red giant star, and Rigel is a blue-white giant. So you have Betelgeuse here. You have the belt stars of Orion. Another star here. You have the Orion Nebula. And then you have Rigel down here at the bottom. On one of Orion's legs. There's more about Hubble's cameras. The warm pastel hues in the Orion Nebula are largely due to glowing hydrogen. There is also a small trace of green from glowing oxygen, a reflection nebula of dust that scatters blue light surrounds LB Orionis, the bright star left of center. Because the light is too faint to stimulate the color receptors in our eyes, the nebula looks greenish-gray when viewed through a telescope. We have this right here. It's a large star. A dark background, and then you can see all the gases here. Some purple and pinkish hues that fade into cream up here, and then fade into brown off to this side. This breathtakingly beautiful color composite picture of a pair of colliding galaxies expands our vision into invisible colors of the electromagnetic spectrum. The collision, which began more than 100 million years ago and is still occurring, has triggered the formation of millions of stars and clouds of dust and gas in the galaxies. The power of all three of NASA's great observatories was needed to produce this image. Chandra's X-ray image reveals huge clouds of hot interstellar gas. The bright point-like sources are produced by material falling onto black holes and neutron stars that are remnants of the massive stars. The Spitzer Space Telescope imaging shows infrared light from the warm dust clouds that have been heated by newborn stars, with the brightest clouds lying in the overlapping region between the two galaxies. In Hubble's view, older stars and star-forming regions can be seen in yellow and white. Brownish filaments of dust are silhouetted. That's pretty fascinating. Look how beautiful that is. God, it almost looks like a candy cane shape. Or a hook. Maybe Maui's hook. Anyway, you've got this brown area here. And red here. More light tan off to the side. Some white areas here, all the way around. Stars, galaxies. It's pretty neat. These images demonstrate how colors are stretched for scientific analysis. At left is an image of the galaxy M83, taken at the European Southern Observatory with a telescope comparable in size to Hubble. The ESO image presents a natural color view of the galaxy as seen in visible light. Above is Hubble's close-up view of the myriad stars near the galaxy's core. Hubble's broad wavelength ranges from ultraviolet to near-infrared, showing stars at different stages of evolution and allowing astronomers to dissect the galaxy's star formation history. The ultraviolet glow of young stars is brilliant blue. The intense glow of hydrogen clouds appears red. Infrared light reveals an underlying population of stars in the galaxy's disk. So here is what they would just see through a normal telescope, and you can see a little bit of the red out here along the edges. But this section right here is what this Hubble image is. You can see this arch of a swirl. You can see this reddish coloring around all the little areas. The galaxy NGC 2841 are especially rich in gas and dust lanes. Young blue stars trace the spiral arms, while older yellow stars crowd the galaxy's hub. So you have the center here, and you have this yellowish area, and you can see some of the yellow stars throughout. And then out towards the edges, you can see more blue colored stars. You even have some red ones in there. Masquerading as a flamboyant piece of modern art, a star-forming region within the Carina Nebula is shown in this enhanced color image, seen in full on pages 104 to 105. Well, I think we better go take a look at that, don't you? Look at that. The Carina Nebula, the largest visible star birth region in our galaxy. This colossal complex in the southern constellation Carina dwarfs star birth regions like the Orion, Lagoon, and Eagle nebulas. This scene is 50 light-years wide and covers only a portion of this maelstrom of star birth. The immense nebula is 7,500 light-years distance. Wow. Amazing, all these gases and colors and stars being formed all throughout. Let's see if we can look at a few more here. Let's see what else we got. Yeah, this is pretty neat. Stellar Spire. This vast elongated branch of dust and gas is 9.5 light-years long, about twice the distance from our sun to the next nearest star. Ghostly streamers of gas boiling off the surface create a haze around the structure, giving it a three-dimensional quality. The column is silhouetted against a background of more distant gas. It almost looks like a dragon. It's a long tail, fanning out. Some wings. And a head. It's kind of looking like puffy clouds and seeing what you see. It's like a Rorschach plot. It's so amazing, some of these pictures. This is M17. Just fascinating. NGC 2467, similar to the Orion Nebula, the distant star-forming region NGC 2467 is 11 times farther away in the southern constellation Puppis. A churning foam of strangely shaped dust clouds forms the backdrop to the newborn blue stars emerging from the gas and dust. Most of the radiation that is eating away at the cloud is being emitted by the single brilliant massive star near the center of the image. Its fierce radiation has cleared the surrounding area, and some of the next generation of stars are forming in the denser regions around the edge. So out here, are the newer stars. And then in the center, newborn stars. And you have this reddish background that fades into orange and then yellow off to the edge here. Let's see if we can find one more fascinating photo to look at. Well, I guess they're all fascinating, but let's see what we can find in here. That's pretty neat. Let's see what this is. This is a large page that shows some of the photos that we can see here. 30 Doradus, the biggest and most prolific star-forming region in or near our galaxy, is 30 Doradus, which is embedded in the Tarantula Nebula, one of the largest digital mosaics ever compiled. This image comprises 15 photos taken by Hubble's Wide Field Camera 3 and 15 by the Advanced Camera for Surveys. It is shown in full resolution detail over the following 4 pages. If the Tarantula Nebula were at the distance of the Orion Nebula, it would stretch from the horizon 1/3 of the way up to the overhead point in the night sky. Spanning roughly 650 light years, this Hubble image reveals the stages of star birth from embryonic stars a few thousand years old, still wrapped in cocoons of dark gas, to behemoths that die young in supernova explosions. The star clusters shown here range in age from roughly 2 million to 25 million years. 30 Doradus has been churning out stars at a furious pace for millions of years. That's pretty fascinating. It's enormous. From here to here is 200 light years across. Just that distance. So then you've got that here and here. It's amazing. Let's take a look at this a little more close up. Look at all these beautiful colors of reds and peaches and oranges and whites and cream, and then the blue background of space. So amazing. We have another view. Oh, swirls. All the different stars throughout. Just so many stars. Stars like our own sun. Older, younger. This is the brightest young star cluster in the Tarantula Nebula. R136 is only a few million years old and resides in one of the most turbulent starbirth regions in the large megalithic cloud. Fascinating. Look at all those stars. Outstanding. I think that's probably good for today. I hope you enjoyed taking a look at this book, which we once again barely got into. It's quite large, and we can always come back